How did the clothes you're wearing, the phone you're using, and the Doritos you're accustomed to enjoying all relate back to atomic theory? Well, in this episode, we'll tell you how. So, you probably just want to get out of class right now and go home to sleep, but
wake up!
This concept of atomic theory may actually influence your life more than you think. So to start, what is an atom? According to ancient Greek philosopher Democritus, all atoms were tiny pieces of indestructible matter that made up all things.
Cool, bro, but how does this, apply to me?
Excellent question, Californian surfer boy. Atomic theory applies to you because all that you are is composed of atoms. But don't leave just yet. Democritus didn't have all of his facts straight. And this simple mistake led to many more years of scientists scrounging to find the truth about atomic theory. Gold star, Democritus, at least you tried. What Democritus had wrong is that atoms are actually divisible, and though they are small, they're not the smallest particles. They're the smallest particles that retain the properties of that element. 2,000 years after Democritus, a fellow by the name of John Dalton came and transformed Democritus' theories to a more established proposal. Dalton mainly claimed that all elements are composed of tiny indivisible particles called atoms. Atoms of the same elements are identical. The atoms of any one element are different from those of another element. Atoms of different elements can physically mix together or combine in simple whole number ratios to form compounds. Chemical reactions occur when atoms are separated, joined, or rearranged. Atoms of one element are never changed into atoms of another element.
Thanks, Dalton.
Let's go to Germany.
Yeah, we're in Germany. Now let's try to apply Dalton's theory. See this here flour? Tight flour. Now let's try to mix the atoms of this flour with the atoms of the brick. It's not mixing! Thank you, Dalton.
After Dalton, scientists discovered three kinds of subatomic particles: electrons, protons, and neutrons.
Jimmy!
Electrons are negatively charged subatomic particles. They were discovered by use of the cathode ray thanks to J.J. Thomson.
Thanks, J.J. Thomson.
Well, we have to give some credit to Robert Millikan for carrying out experiments to find the quantity of charge carried out by an electron. Protons were discovered by Eugene Goldstein.
Thanks, Eugene Goldstein.
Protons are positively charged subatomic particles. And then we have neutrons.
Jimmy, get away from here!
Neutrons are the Swedens of the subatomic world. Always neutral, they have the same mass of a proton. They were discovered by English physicist James Chadwick.
Thanks, James Chadwick.
Now, most scientists have believed that the atom looked like the plum pudding model. Ooh, that's fun to say.
Plum pudding.
Basically, the raisins would be the electrons, and the pudding would be the positively charged material.
Plum pudding.
Now, we do have to thank Ernest Rutherford for discovering the nucleus through his gold foil experiment.
Gold foil.
Sorry, Californian surfer boy, doesn't quite have the same ring to it. The nucleus is the central core of an atom and is composed of protons and neutrons. The electrons just occupy the rest of the atom. However, with little information about atomic theory, Rutherford's atomic model could not explain the chemical properties of elements. So a fellow named Niels Bohr stepped up and proposed that an electron is found only on a specific circular path around the nucleus. These circular paths were called orbitals. Orbitals have a fixed energy, which is called an energy level. A quantum of energy is the required amount of energy to move an electron from one energy level to another. That's why we have light. As the electron moves down an energy level, the energy released is visually perceived as light. You see, Bohr was completely wrong because his model would have led to the collapsing of the atom. The guy who got it right was Erwin Schrödinger.
Thanks, Erwin Schrödinger.
He created the modern description of electrons in atoms.
Quantums everywhere.
Ja, German girl, the quantum mechanical model. Basically, he said that we can't know the precise location of electrons, but that they are in a cloud around the nucleus. So to summarize, an atom is the smallest particle of an element that retains its properties and its identities of the element. So there are three types of subatomic particles: protons, electrons, and neutrons. Electrons are negatively charged, protons are positively charged, and neutrons are, you guessed it, neutral. In the nuclear atom, protons and neutrons both compose the nucleus, and the electrons are clouded around the nucleus. Thanks everybody for watching this video. We hope you enjoyed it. Come back to Crash Course Chemistry for more informational videos. See ya!